Welcome to Ask and Learn.
Okay, so for part A, we are given that f is little o of g, right, where f and g are functions, and we want to prove that f is big O of g. Okay, well, so since f is little o of g, we know that the limit as x goes to infinity of the ratio of f and g must be equal to 0 by definition. Since the limit approaches 0, it doesn't really matter if we take the absolute value, right? Because the absolute value of 0 is 0. So therefore, we get that the limit as x approaches infinity of the absolute value of f over the absolute value of g is equal to the limit as x approaches infinity of the absolute value of the functions. All right, and this has to equal 0. Well, if the limit here is equal to 0, that implies that the absolute value of f over the absolute value of g must be less than or equal to some constant, c, for x greater than some k. So when x is sufficiently large, okay, well, we can just multiply this inequality both sides by the absolute value of g, right? So it'll cancel out on the left, giving us just the absolute value of f. And then we end up multiplying it here on the right, okay? And this is the definition of big O, right? So this implies then, since the absolute value of f is less than or equal to absolute value of g times some constant, then f is indeed big O of g. Okay, so then we need to move on to the second part here. And so this is to say that we then have that f is big O of g. And we want to show then that it's not the case necessarily, maybe sometimes, but not necessarily a little o of g. Okay, so let's define these functions. We'll let f equal 1 and g equal 1 for all x in R. Okay, so we will note first that f is big O, right? Because the absolute value of f, which is equal to the absolute value of 1, which is equal to 1, is less than or equal to 1, which is equal to the absolute value of g for all x. Okay. This is the case, of course, where c equals 1 and k can equal 0. All right, but if we take little o, right, which is going to be the limit as x goes to infinity of f over g, which is equal to the limit as x approaches infinity of 1 over 1, which is really just the limit as x approaches infinity of 1, which is going to equal 1. Well, that does not equal 0. So therefore, f is not little o of g.